Okay, good morning, Honors Math 2. You have a sub today, and I thought we would start off by just going over one of the questions, one of the hardest questions on worksheet 10-1. So get out your homework and look at number 14, and I'm just going to go over what that answer was with you guys. Okay, so again, we are changing it from standard form. Whoops. To vertex form, and vertex form looks like this. It has to have a y equals, it has parentheses, plus k. So your first thing always to do is to move the c value, and this is a, b, and c, to move the c value to the other side. Oh, and we also make that equal 0, or drop the y. We'll put it back when we get to the vertex form. So we have negative 16 equals 3x squared minus 18x. Now we don't complete the square when we have a 3 there. So the next thing I'm going to do is take out a GCF. And I don't have to do it from both sides. And I'm not taking out the x, just the number in front when I take out the GCF. Okay? And now, just to kind of, because I've already taught you this, to skip one little step, I'm going to put a box here, and whatever you do to one side, you got to do the other side. So you have to be very careful. There's a 3 distributed. It has to be distributed to the box, so over here you have to put a box. Most common mistake. Then you complete the square. You take half a b and square it. That is 9. So this is 9 in both boxes here. Then you factor. The b value that you took half was negative 3, so this is x minus 3 squared, because remember again, negative 3 times negative 3 is 9, and negative 3 plus negative 3 would be negative 6. Over here we have 27 minus 16, which is 11. And then we would move the 11 back over to write it into vertex form. And for it to be in a form, it has to be an equation, you have to have an equal sign and a y and an x. And that's your answer. And then from there you could tell your h is 3 and your k is negative 11. Okay? So now that you've gone over that, I need you guys to hand in your homework. So you can either have one person from each group, put the groups in the basket on the table right here, or you can have the sub picking them up, either way what you guys want to do, whatever the sub wants to do, and put them in stack. So either you put them in stack and have one person in each group bring it up, or have the sub collect it like I usually do. Okay? Now I need you guys to get out notes for 10.2. So now instead of actually finding a vertex form in the vertex, we're actually going to solve. And when you solve something, you're going to see what x equals. So I'll give you some time to make sure your homework's in and make sure that you guys are getting out your notes. So again, solving, we're finding what x equals, and you guys should know anytime we have a quadratic, we're going to have 2 answers. Every once in a while you have the same answer twice, but almost everything. So we're going to have x equals and 2 answers. Okay, so you guys know they're solved by square rooting, which was last chapter, solved by factoring, which was last chapter. This is another method, solved by square rooting. I'm sorry, solved by completing the square, which will also be square rooting. Okay, so I'm hoping you got your notes out by now. Okay, so let's talk about warm-up really quick. Okay, so I want to just take the square root of 24. Remember, we leave it simplified radical, so you can do 4 times 6 or 8 times 3. This would be 2 times 2, 2 times 3, the 2's match, so we would write this as 2 radical 6. We don't write plus or minus in the front unless we're solving for x and finding out what x is. We're just simplifying, so you guys understand the difference. Okay, so what are we doing today? Here we go. This is how you solve by square rooting. Okay? Use this method to solve quadratic equations when the equation is not easy to be factorable and the b term is even. So here is a quadratic equation. So like last chapter, when it was in this form, we solved by factoring, doing an area model, zero product property. But sometimes they're not factorable. Sometimes they are. And sometimes it might be easier just to do solve by completing the square. This b term, it's helpful if it's even. And you probably noticed that on 10-1 homework. Remember that one we had 5 and we had to go 5 divided by 2 and square it. So it just made it to be a fractional decimal, so it's easier if it's even. So here's the first thing. We're going to move c to the other side, which we did last time. We're going to find the value that completes the square. Okay, remember that's b divided by 2 squared. And whatever we do to one side, we're going to do the other side. We're going to write it in factored form. So that's going to be with the x either minus or plus b over 2 squared. Okay? And then this is new. So instead of moving it back over and making y equals in vertex form, now we're going to leave that c value over there and we're going to solve by square rooting. So we're going to take the square root of both sides. There are going to be plus and minus now. So you're going to have two answers, plus or minus. Okay, so if you understood last time, it's just a little bit different method of doing last time. But we're solving for x, so we're actually getting the x-intercepts, not the vertex, what we did yesterday, or Friday, sorry. Okay, so let's try a couple. So here's the first one. I'm just going to kind of go through and I'm just going to show you lots of different, remember there's going to be two answers. So the first thing you do is move the c value over. Not anything different than last time. I'm going to put a square because I'm going to complete the square. And really quickly before I go on, this was not factorable. You cannot do a diamond problem and think of things that multiply before and add to be negative 12. It's not going to work. That's why we do this method. Remember, we take half of the b and square it. So that's negative 6 squared, which is 36. These are always going to be positive number because when you square something, you always get a positive. Then you would write this as x minus 6 squared, so factored form. This would be 32. So now, yesterday, or Friday, I mean, or the problem I just did on number 14, we would move the 32 back over and we would write it as an equation, or not. So now we are going to solve. So from last chapter, you're going to take the square root of both sides. Square root and squared cancel out. But now we're going to be simplifying radicals a lot. So this is 16 times 2, or you can do 8 times 4. 4 times 4, plus or minus 4 radical 2. And then to get x by itself, we're going to add 6 to both sides. So our answer would be x equals 6 plus or minus 4 radical 2. Don't have to change it into decimal. I don't want you to change it into decimal. The only time I'd have you change this into decimal if it was a word problem or we actually needed to find the exact x-intercepts and we needed a decimal to graph it. Okay, let's try another one. Same type of thing, almost the same question, but this is a 23. Again, not factorable. Nothing multiplies to be 23. It's a prime number. So to solve it, we have no choice right now other than completing the square. Again, step 1, move the c value, which is the constant, to the other side. We're going to complete this square. And if this is not a 0 and it's a y, you're going to put 0 there, so you know, because that's going to come up. Okay, same as last problem, half of negative 12 squared. Again, 36. Remember, these are all going to be perfect squares. This factors into x minus 6 squared. Remember, whatever this sign is, that's the sign that goes there. And if we add these two together, we get 13. Take the square root of both sides. Now, the difference between this one and the last one is 13 is a prime number. I cannot take the square root, but I have to be plus or minus. And then the last thing is to solve for x. We'd add 6. And it's better if you can write the 6 in front and the radical in the back. You'll see when we get farther on in this chapter. Two answers because it's plus or minus. Now, if you want to, you could write it 6 plus radical 3 and 6 minus radical 13, sorry. You could write it like that. Okay, so almost the same question. One of them we could simplify the radical. You have to simplify it and keep it in simplified form. This one we can't. Okay? Okay, next example on the same page of your notes. Sorry, I can't flip the page. Now this one is different. And what is different? Okay, so if you said that the 24 is all already moved over, you're right. So we're going to skip the first step. We don't have to move the C value, it's already over. So we're going to just get on to complete the square. Whatever you do to one side of the equation, you have to do the other. Okay, what is going to go in there? Remember, half of 16 squared, or negative 16 squared, which is going to be 64. Remember, when you factor it, it's always the same sign as your b term. And then when I add these, I get 88. Take the square root of both sides. They cancel out. Now, square root of 88 looks like I can simplify that. 2's match. And we have 11 and 2 left. So anything that's a multiple of, 4, 8, 9, something like that, you're going to be able to simplify it. So this would be plus or minus 2 answers, 2 radical 22. And then the last step is to solve for x and get x by itself, so we're going to add the 8. Again, I'd rather you write the number in front. You don't have to write this equation as 2 separate ones. You could just leave it like that. Okay, one more before we get to the back. So, done 2 where you can simplify the square root. 1 you couldn't. This one's going to be a little bit different. Again, you can skip step 1 also in here. I know on your paper this x squared is really tiny, but it's supposed to be x squared, little typo. So I can skip this, so I'm just going to go right to completing the square. Whatever I do to one side. And some teachers don't put a square there. I thought, what? They just put a little line. I like to put a square because we're completing the square. Half of 20 squared is 100. So I'm not going to do that whole b minus 2 right now. You should be able to get that. This would factor x minus 10, x minus 10, or x minus 10 squared. This would be 25. Take the square root of both sides. Okay, again, if we were doing solving by, or putting it in vertex form, we wouldn't do this. We'd actually move the 25 back over. We're actually solving. Now, this is the first one where we can actually have a perfect square and solve it. Again, what's the square root of 25? Yes, plus or minus. Don't forget the plus or minus. And then you're going to add 10. So make sure that you actually simplify this like we did last chapter. So this would be x equals 5, or 10, we'll just write 10 plus 5, and x equals 10 minus 5. A few of you on the test didn't simplify it. So your answer is 15 and 5. If you left it like this, you will not get full credit. You actually have to simplify. Okay, turn the page of the notes to the back. We're going to do another one like this, and then I'll probably have you try one. Okay? This right here, also, already the C's moved over, so I'm on the back of the notes now. Go straight into completing the square. What's going to go in the square? Yeah, 81. Now I've done a lot with minus because a lot of people just want to put a plus every time. It's not always a minus, it's whatever this sign is. So negative 9 times negative 9 is 81, negative 9 plus negative 9 is negative 18. This ends up to be 144, should key to you guys, hey, that's a perfect square. So x minus 9 equals plus or minus 12, no radical. Then we're going to add 12, or I'm sorry, add 9. X equals 9 plus 12, and x equals 9 minus 12. You have to figure out both answers. So we get 21 and negative 3. So what does that answer mean? Well, it actually means that this first problem, if I would have wrote it like this and moved this 63 over, it was actually factorable. So if you actually did a diamond problem and you figured out what multiplies to be 63 and adds to be 63x squared, sorry, and adds to be negative 18, it would have actually been 21, would have actually been negative 21 and positive 3. And so you would have, right, x minus 21 and x plus 3. And when you solve it, you'd be the opposite, and you would get the same exact answer. So later on in this chapter, you'll make a decision. Should I factor? Should I complete the square? Should I do something else? This one, up to you. Right now, I want you to solve by completing the square. But if you get numbers that are actually whole numbers, it was factorable in the beginning. But if you get radicals, it was not. Okay. I want you to try this one. Actually, the next two. So try that one in the top right and this one in the bottom left. I'm going to give you guys a couple minutes, and then I will show you the answers. I'm going to remove this, give you a couple minutes to solve it. Keep going. Do the next one too. And then make sure you guys are talking to your group about the answers. Give you guys a couple more minutes. Now the second example I'm asking you to start, okay? Realize that you got to move the C value over. I'll show you guys that in a second as you guys are working. You guys about 2 more minutes. And if you don't finish the second one, not a big deal. Hopefully at least finish the first one. And again, share your answers. Give you guys 1 more minute. Do not go on to the next question. It will trick you. Okay, I'm going to stop you guys. And I'm just going to show you the answer to the first one. First one you should have got 5 and negative 15. Okay? Some of you may have put a minus there instead of a plus, but remember this is a positive up here. So you need a positive. Okay? Hopefully you guys got that right. Okay, now the next one, I'm just going to put it like this. The first thing I need to move over, whoops, you can't see that, sorry. The first thing you need to move over is that 26. Okay, I cannot solve it and complete the square if I actually have a C value there because I'm finding a new C value. So that's the first thing I did. Okay, moved it over. 8 minus 26 was negative 18. I completed the square. Half of negative 10 is negative 5. Negative 5 squared is 25. Did that to both sides. I got x minus 5 quantity squared equals 7. I square rooted both sides. I got x minus 5 equals plus or minus radical 7, and then I add the 5 to the other side. Okay. This one over here on your top right was actually factorable because we got a number here. This is not factorable. Even if you try to move the 8 over, like we did last chapter, and make it equal 0, it's not factorable. Okay, now, next one is a little tricky. Now you know this from the little question number 14 that I went over earlier. You know how to do it with this, but you might forget something as you're doing this, or maybe you missed number 14 on the last assignment and you need more help with this. So let's go on to the next assignment. Okay, so what's different on this one is there's a 2 in here, and everything else had your A value as 1. Okay, now, I know all three of them have a GCF. Don't do it. Do step 1, step 2, just like you normally, or step 1 like you normally do. So add the 14 to both sides. So you get 2x squared plus 8x equals 14. You notice I haven't put the complete the square yet. Now I have to take out a GCF. So I only have to take it out on the right hand or left hand side. So 2x squared plus 4x. I am going to complete the square there in a second. And over here, whatever I do to one side, now remember there's a 2 outside there, so you have to put a 2 outside here. So if you distribute this 2, you'd get back to 2x squared plus 8x, but you'd also get 2 times square. You got to put the 2 over square there. So half of 4 squared is 4, so half of 4 is 2. So we have 2x plus 2 squared. Over here we have 14 plus 8, which is 22. Well, now this is back to last chapter. We're just going to solve by square rooting. What do we need to do first before we square root? Yeah, we need to divide by 2. So we get x plus 2 squared equals 11. Now we can square root both sides. So we get x plus 2 equals plus or minus radical 11. And to solve for x, we would subtract 2. So our answer would be negative 2 plus or minus radical 11. And again, if you want to write it as 2 separate ones, you can, but you don't have to. Okay, so let's take this into graphing and finish this up. Okay, this is the part where you guys mess up usually. We forget the 2 in front of the square and we get going too fast, so be really careful on those. Okay. We are going to now graph this. Now this is actually factorable, and I can graph by factoring from last chapter and use zero product, but I want to factor by vertex form. So the first thing I want to do is I want to change it into vertex form. So that is from 10(1). So I'm going to make this a 0. I'll put it over here. I'm going to move this c value to the other side. And I'm going to complete the square. Okay. Half of 2 squared is 1 squared, which is 1. So over here I have 9 equals, and I'm going to factor this, x plus 1 squared. Now to change this into vertex form, you got to move the 9 over. And you have to write it as an equation, so it would be y equals x plus 1 squared minus 9. So that was from 10.1. Okay? That is going to tell you the vertex. Your h is negative 1 and your k is negative 9. So we're going to graph that. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 goes off the graph a little bit. You should know from this equation in standard form what the y-intercept is. It is 0, negative 8. Now you might want to use that. You're also using the a value right there. Okay, now I don't want to graph this yet because I want to find the x-intercepts. Okay, if I factor it, I can find the x-intercepts, but I want to solve this by square rooting to show you also it gives the x-intercepts. So I'm going to go back to this equation and I'm going to solve it, not when I moved it to vertex form, but move it back here and I'm going to solve it by square rooting. So square root of 9 is 3 plus or minus 3. Square root cancels, and then I'm going to subtract 1. So I get x equals negative 1 plus 3, which is 2, and x equals negative 1 minus 3, which is negative 4. So we have an x-intercept of negative 4, 0, and 2, 0. So a lot of things you can double check if that is right. I'm going to draw in the parabola though first. So if I look at the axis of symmetry, even though I didn't draw this really good, axis of symmetry should be right in the middle of those. It is, which is your vertex form. If you don't want to solve this by this method, what I think is easier, you could also factor, oops, I don't know why I put a parentheses, sorry, this, and this would have factored to x plus 4, x minus 2. I'm just going to do it fast. You would have set it equals 0 and you would have got your 2 x-intercepts, which is the exact same thing we got when solving square root. And when we get to the test, I don't care which way you do it as long as you get the x-intercepts. Okay, we're going to try one more like that before you guys can go on to the homework. So last question. Okay, I'm going to start a little bit different order this time. And I'm going to say what the y-intercept is. Remember, the y-intercept in standard form is the last number. I can use it on the graph or I can not. On the last graph, I didn't even talk about it on the graph. Oh yeah, I did. Okay, but I'm going to write this in vertex form because I'd much rather graph it in vertex form. So I'm going to take this equation, set it equals 0, move the c value over, and complete the square. Half of 4 squared is 4. So I get 9 equals x plus 2 squared. Take the square root of both sides. Square root of 9 is plus or minus 3. And then we would subtract 2. So we get x equals -2 plus 3 and -2 minus 3. Oh, I didn't even write in vertex form. We'll go back. Sorry. So your x-intercepts would be x equals 1 and x equals -5. Sorry, I totally skipped that part. Got way too busy. 1, 0, 2, 3, 4, 5, 5, 0. Okay, now let me go back to there. I need to go there and write that in vertex form. So remember, I had 9 equals x plus 2 squared. So to write that in vertex form, you're going to move the 9 over, and you have to write it as an equation. My bad there. So vertex form would be y equals x plus 2 squared minus 9. Just make sure everything comes together here. Okay, we should know our line of symmetry should be at x equals -2, which is the same as our h value, and our k value is -9. We could also use our y-intercepts, 1, 2, 3, 4, 5, to help us. And we can also use an a value of 1 to help us. And everything should come together. Okay? Okay, once you're done with that, pull out your homework. And let's just talk about it really quick. It's pretty much like you guys just did. So if you look at it, this front is just solving by completing the square. You should get 2 answers, plus or minus every time. Okay, be careful in those because they have a coefficient. And then I gave you 2 graphs to do. So the graphs on the back, same thing. Put it in vertex form, find the vertex, x-intercept, y-intercept on both of those. Okay? Okay. I will see you guys tomorrow on Tuesday. We'll kind of go into a next part of this, but you can now see why it's much easier to have this in vertex form. You can do so much more of the graph if you know vertex form. Again, I could have factored this one and got those x-intercepts also. Just gives you another tool to figure this out. Okay, see you guys tomorrow.